Hello and welcome. Today we are going to be talking about how to name acids. So there's two types of ways that we can name acids. So the first type are acids that do not have oxygen. Okay, so do not have oxygen. Okay, so what we're going to be doing is we're going to look at how to name them and how to come up with these formulas. So once again, the best way I think to get better at this is just by jumping in and trying doing some examples. So the first one we're going to look at is HF. Okay. Now this here is called hydrofluoric acid. Okay. Now, there's a couple things that I want to talk about, and once again, like I said, we'll do a lot of examples so you guys get familiar with this. So the first thing I want to note is that when we're naming our acids that do not have oxygen, they're always going to start with hydro, they're going to have ic, and they're going to end with acid. Okay, so let's try another one. Okay, if I had HBr. So once again, as you can note, these do not have oxygen. So I'm going to start my naming with hydro. Okay, this time instead of fluorine, we have bromine. So it's going to be hydrobromic acid. Okay, so we have the hydro, we have the bromic, and we have the acid there. Okay, let's try one more. Okay, if I had HCl. Okay, so once again, at this point, what I want you to do, pause this video and see if you can come up with this name. Okay, try it, and then when you're ready, click resume and see if you got it right. Okay, so try that now. Okay, so for this one here, you should have had hydrochloric acid. Okay, so once again, it starts with that hydro, it has the ic, and it ends with acid. So a couple things I want you to know before we try a couple other ones is that acids are always going to be in aqueous form. Okay, so whenever you're doing these should all be in aqueous form. Okay, now the next thing that I want to talk about is how we come up with these formulas when given the name. Okay, so if I gave you hydrofluoric acid, how would we have gotten HF? So how you would do this is by looking at the root word. Okay, so I'm going to just highlight here. So we have fluor. Okay, we have brom and we have chlor. Okay, so from those root words, you should be able to pick out that fluor means fluorine. So what you're going to do when you're trying to come up with these formulas is you're going to start with that root compound, so that root element. So that root element would be fluorine. Now, what you're going to need to be able to do is to come up with what that ionic charge is. So fluorine has 7 valence electrons, and we know that in a valence shell, there wants to be 8 electrons. So it's going to take 1 extra electron in, and it's going to become 1 negative. Bromine does the same thing. And so does chlorine, actually. They're all in the same family. They're all halogens. So that's your first step always, coming up with what the charges of those elements are going to be. And not every single time is it going to be 1 negative. It just happens to be this for this example. So what we're going to do is we're going to add hydrogens because acids always start with hydrogens or at least contain them in their compounds. So how many hydrogens would we expect to add? Well, we have a 1 negative charge here. Okay, if you recall from our synthesis reactions, okay, fluorine, 1 negative, is going to need hydrogens to balance itself out. How many hydrogens is it going to take? Well, it's going to take 1. because it's a 1 negative charge, so we need 1 hydrogen to balance it out. And when we add that 1 hydrogen in, we get HF. Here, once again, the charge is 1 negative. Because it's 1 negative, it means we could add 1 hydrogen to it. And lastly, chlorine, once again, 1 negative charge means we can add 1 hydrogen to it, and we'd get HCl. Okay, so let's try one more, and then I'll get us to try, or I'll get you guys to try it. Okay, so what if I had the name hydrosulfuric acid? Okay, so that's my name that I'm trying here. So now what we're going to try to do is we're going to try to come up with the formula. Okay, most times I will give you the name and I'll expect you to come up with the formulas. So what you're going to do is you're going to look for the root word. So if I take a look here, I see sulfur. Okay, or sulf with the U. So what I'm going to do is I'm going to put S here. Now, what I need to do is I need to figure out what my charge is. So my charge for sulfur as an ion is 2 negative, and you can find this on your periodic table. Now, when I have this here, how many hydrogens do I need to balance this out? Well, I'm going to need 2 hydrogens to balance this out. So I would get H2S. And once again, the charge goes away now because I balanced it with my hydrogens from that charge to here. Okay, so let's try one more. Okay, what if I gave you this here? Hydronitric acid. Okay, so pause the video right now, try this question out, and see if you get the right compound formula. Okay, so go ahead and take a second and try that out. Okay, so hopefully you tried this out. So the first thing we're going to do, once again, I see nitric, nitrate, or nitrogen. So I have N. Now nitrogen makes a 3 negative charge when it becomes an ion. So what that means is I need 3 hydrogens to balance it out, and I get H3N. And that's my formula there. Okay, now once again, like I said before, we need to put our states. So our states should be aqueous. And I didn't put it up there, so I'll do it right now. Okay, so that's how we name acids that do not have oxygens. So our second type of acids that we will be coming into contact with are ones that have oxygen. So we'll try our next ones out. So these ones have oxygens. Now, in order to do these questions, we are going to need to recall our polyatomic ion. So what I'm going to do right now is I am going to pull out my polyatomic ion sheet. Okay, and by now you should be able to name all the different polyatomic ions. So if you're given chlorate, you should be able to come with chlorite, hypochlorite, perchlorate, all of them there you should be able to come up with. And once again, this is what I had from the previous time we tried it with our carbonates from my previous videos on how to name polyatomic ions. Okay, so if you're not too sure how to do it, check out that video, it'll help you out. Now, one thing you may have noticed from this polyatomic ion sheet, if you're taking a look here, there's another section over there that I have included. Okay, so it might be a little bit tricky to see it from this video, but once again, if you go online, you can find this polyatomic ion sheet, and you'll be able to see what our naming of our acids here. Okay, so what I'm going to do is I'm going to go back to this example here. And once again, if you take a look at that polyatomic ion video, that's where I got these from. Okay, so I have my carbonate, carbonite, hypocarbonite, and percarbonate. Okay, now what I'm going to be doing is I am going to change these into acids because we can do that if we add these into water. So what's going to happen is we are going to get different compound names. So here are my compounds as polyatomic ions. And what we're going to do is we're going to change these to acids. So just bear with me for now. It may not make too much sense, but after we do some examples, it will. Okay, so if I have carbonate, I'm going to start with the normal one. Now, the first things I'm going to do is I'm going to take these polyatomic ions and I'm going to make them into acids. And once again, you do that by dissolving them in water, and we'll be seeing this later on through this unit as well as future units in this course. But before we can get that, we need to make sure we know how to name and do formulas. So we have, let's start with carbonate here, CO3 2 negative. So if I'm trying to change this into an acid, how many hydrogens can I add? Now, if you just scroll back in this video, or if you take a look here, how did we figure out how many hydrogens? Well, we have to look at the charge and we have to balance those out. So the same thing is going to happen with these ones. So carbonate has a 2 negative charge. So how many hydrogens should we put? Well, we're going to put 2. So we will get H2CO3. And once again, the charge goes away because I'm balancing it out with my hydrogens. Now, because this is an acid, I need to put my aqueous sign. Okay, same thing with the carbonate. What would this new formula be? It would be H2CO2, and it's also aqueous. Once again, how did I get 2 here? Because of that charge. That 2 negative charge tells me how many hydrogens I'm going to add. Same thing here, HCO, which is aqueous there. And lastly, if we had H2CO, and we also have, for the top one, we have keep losing my paper here, H2CO4, aqueous as well. So if you're able to come up with these polyatomic ions, you should be able to do the acids, no problem. All you're doing is you're just adding how many hydrogens correspond to what the charge is there. Now, the last thing we're going to do is we're going to come up with our new acid names, and I'm going to put them here. So how we do this is once again by looking at this sheet. So for the normal atom, what we're going to do is instead of it ending in ATE, it's going to end in IC acid, ic acid. So if I go over here, so instead of it being carbonate, I'm going to take out that ATE and I'm going to replace it with IC. So this is going to be carbonic acid. So just like I did before, I'm just taking out that ATE and I'm putting IC acid. Sorry, there you can see it there. If you take a look at the next one underneath, okay, now instead of IC acid, and once again, I know it might be hard to see in this video, but you should have your polyatomic ion sheet with you while doing this. This here has OUS acid. So carbonate would now be carbonous acid, carbonous acid. Okay, and if we take a look, so now we have our normal, we had 1 less, now we have 2 less. So same idea, it still starts with hypo and we have OUS acid. So I'm going to do that over here. Okay, so now we have our starting hypo, carbonous acid. And whatever I'm underlining, that's actually what we have here, okay? And now let's do the last one, which is 1 more oxygen. So this one still, it starts with per, but it has the ic acid. So we have per, carbonic acid. So acid, IC, and PER, and that's our naming there. Okay, so what I want you guys to do right now, okay, is I want you to try for chlorate, okay? So if you take a look here, you have all your chlorate, chlorite, and so forth. But what I want you to do is I want you to change these into acids, and I want you to come up with the new acid names. Okay, so take a minute and see if you can do this. Okay, try it out. And then when you're ready, click resume and see if you got the right answers. Okay, so pause it now and take a second and try that out. Okay, so hopefully you tried it out. Okay, so what I'm going to do, the first step I'm going to do is I'm going to come up with all my formulas for chlorate. Okay, so chlorate is ClO3, 1 negative. I have 1 more. I have 1 less. And I have 2 less. Okay, so those are all my formulas. Once again, you could just take a look at your polyatomic ion sheet to see if you got that right. Okay, now the next thing I'm going to do is I'm going to change these to acids. So how many hydrogens do I need to add? Well, I need to add 1 because that's what my charge is. So I have 1 negative, so I need 1 hydrogen to balance that out. So my acids now will become HClO4, HClO3, HClO2, and HClO. Okay, and once again, how did I get these? 1 negative, all these charges, 1 hydrogen I'm adding to each of them. Okay, and once again, these should all be aqueous. Okay, so now we have the proper formulas. The last thing we need to do is come up with these proper names. Okay, so I'm going to start off with my chlorate because that's my normal one. And once again, if you have your polyatomic ion sheet, it should end in IC acid. So I'm going to have my chlor, because that's my root of my word. Okay, but instead of being chlorate, it's going to be chloric acid. Once again, that IC acid. I'm going to just jump up and I'm going to do the top one. This should have been perchloric acid. I have 1 less. So now this is going to be chlorous, O-U-S acid. And then I have the last one here. So this is my hypochlorous acid. Okay, and that's how we name acids. So we looked at ones that have no oxygen and we looked at ones that do have oxygen. Okay, and we're going to be using all of these throughout our semester. So please make sure that you do know how to name these. Okay, thank you for watching and have a good day.